right? Okay. So far we have completed three modules. That is the first stakeholders and drone rules 2021, then basic principles of flight, and then we have talked about RT procedures also. Okay, RTR procedures. So these are the three important initial modules. Now we are going to deep dive into the types of UAS. Okay. So first is the fixed wing operation aerodynamics. Though we are actually getting certified only on rotorcraft, but we, as a drone pilot, I need to understand how all the three categories of UAS apply. Okay, how they operate or how they follow. So when you learn more about fixed wing operations and aerodynamics during that kind of license, you may have more detailed understanding of it. Okay. When you are learning rotorcraft, your focus will be more on the rotorcraft. When you are learning hybrid, you will have more sessions on hybrid topics or hybrid UAS topics. Okay, so accordingly, so here we will have more focus on the rotorcraft. Okay, which is the second module from now. Okay, so we'll be doing fixed wing operation first to understand how the fixed wing operates and the aerodynamics around it. Whatever we have learned, the same basic principles is applicable over here to understand the fixed wing operations. But then what are the small components that will give us more clarity of operations? Okay. So what are fixed wing drones? The fixed wing drones are nothing but they are aeroplanes or airplanes which generate lift under the wing due to forward airspeed, which is produced either by internal combustion engine or electric motor mounted with propeller. Okay. So you can see there is a fixed wing. Okay, you can have either internal combustion engine which is powered by gasoline or diesel, or kerosene also, depending upon the type of engine, or a electric motor which is called as a BLDC motor. Okay, whereas this fixed wing, they require either handheld catapult or runway to take off and can fly continuously over longer distance as opposed to hovering. Okay, so it cannot hover, right? If you see here, the drone watch is there, that is a Predator drone. It requires a runway to take off. Okay, so this basically is a defense drone or defense which uses the fixed wing remote pilot aircraft for reconnaissance missions or even attacking the enemy territories and all that things purpose. Okay, so this drone basically is predominantly initially used for reconnaissance mission. Like you must have seen in Afghanistan, or even what is that? Not Obama, Bin Laden, right? Who was killed. That time there were two drones. This type of drones were flying over that area, and they're giving a guidance. And there were some missiles were attacked using these Predator drones. Okay, whereas there are smaller types of fixed wing. They can be handheld catapult. Like you can throw it by hand, or there could be a catapult mechanism. The spring loaded mechanism is there which will push the aeroplane into the air at a very high speed. Okay, that is what can be done. So this is what it is. Either you can either by handheld or catapult, or it requires a runway to take off and land safely. Okay, the advantage of this fixed wing is it can go cover longer distance, as well as it can go at very high altitudes. Okay, these are the two advantages, but it cannot hover at a particular location because of its forward airspeed. Okay, as it is continuously moving in a forward direction, that's why it cannot look at a one particular way. So अगर उसको वापस वो location पे आना है, तो it has to circle and come back. Okay, so it has to do in that scenario. So they have to plan the missions such a way, like if they have to surveillance a particular area, they will just keep on circling on that area at a particular altitude at very height. It is not visible from ground for people to see it, and they will be having a very high quality payloads. The camera systems, all the devices or the payloads, whatever they have been put, they will be very high quality. I mean, at such, even at let's say 2000, 10,000 height, they can still see a very clear things on the ground. Okay, so that kind of optics or the payloads, they would be having it. Okay, so there are different types of fixed wing drones based on the wing type. So one is the straight wing. You can see here the straight wing, right? It is a straight wing, but there is little bit bend. Okay, like rectangular straight wing, tapered straight wing, or round or elliptical straight wing. Normally, the more rounding shape is there. Okay, I mean, normally if you see in aerodynamics perspective, the more the curvature is there, the more efficiency is here. So that's why you see here the square, the rectangular shape, straight wings. They offer less efficient. Then little bit tapered hai. Okay, they are little bit curved. So they give you moderate efficiency, but highly efficient whenever you have rounded or elliptical straight wings. Can you tell me where this kind of wings you have seen in past? Anytime you have seen this kind of wings?
World War II aircraft Spitfire and all had this.
Correct, absolutely correct. So World War II, the smaller aircraft which was used for reconnaissance mission or attacking and all those things, and this was actually efficient. But these kind of wings cannot be used on a bigger aeroplanes because it will not give you that area what is required. That's why if you see in a bigger aeroplanes like your Boeing and everything, we have a delta. Okay, delta mechanism. Okay, the swept wings, or it is called also swept, also not delta, but it is swept wing. Okay, so normally you will see this type of wing structure in a bigger aeroplanes. Okay, so slightly swept wing, moderately swept wing, highly swept wing. Now this type of combination, I mean this type of wings design depends again on the length of your fuselage also. Okay, and the kind of aeroplane you are designing. So a lot of things. So you can't just I mean you have a Boeing and you can't use a small wings. So the moment it has amount of length of the fuselage, automatically the wing size will also change accordingly. Okay, so you can't have. So now you must have seen that this might be available in Boeing or your Airbus, but this can be seen in a smaller aircraft. But this can be available in a smaller fighter jets. Okay, so depending upon whatever the aeroplane is, the way aeroplane design, that will define the wing size also, the way the wing design. So it is not only just very simple that you can design whatever way you want. It goes lot of study, lot of what is that, wind tunnel, where they study the pattern of the particular wind on the wings. Okay, so that is what they study, and based on that they use whatever it is required. So there is a lot of even softwares are available where you can design the wings without actually manufacturing or making a prototype, and test them also. So in ANSYS software or SolidWorks, those kind of software you can use. I think Shubham might be aware of those kind of software, and they might be using in mechanical things also, right, Shubham?
Yes, we use them a lot for simulations and for designs also.
Correct. Then delta is simple delta or complex delta. These are basically used for high speed subsonic or supersonic flights. Okay, so you might have seen recently B2 bomber आपने देखा होगा, right? So it is almost similar to this kind of design, right? So these are basically for a very high speed subsonic or supersonic flights, or especially your even fighter jets, they uses this kind of designs. Okay, where the wing size is very small, because here wing plays a very minimal role. Okay, it doesn't play much role in flight, because here wing is only to stabilize or to make it stable, whereas maximum flight is because of the engine what it powers. Okay, that thrust what it gives. So entire the movement of the aircraft is by the engine. The wings are basically to stabilize or change the orientation for that purpose only, not much of the flight it is uses. Okay, if you use only the engine with vector thrusting, then you don't require wings. You will not require wing also. Like right now, you must have seen the rockets used by SpaceX or Blue Origin, or even recently the Honda has done the testing. They are all using vector thrusting, all those things on the engines what they are using. Okay, even the SpaceX. What is that, Starship, they all uses this all mechanism. So they are not using any wings also. There is only very minimal fins are there. Okay, but which doesn't play much of the role. Okay, everything is on the engine. The engine makes the body stable and depth change the direction and everything. So what are the parts of the fixed wing? So we can see this is like an aeroplane only. Okay, you can see here there are wings. Okay, on the both sides there is a fuselage. Then you have propellers with the engine on the wings. Then you have a landing gears. Okay, you have a fuselage similar to like your aeroplane. Then you have vertical stabilizer and horizontal stabilizer. So vertical stabilizer will have radar. horizontal stabilizer, will have rudder. So this is similar to an aeroplane, but only smaller in size, where there is no pilot inside. It is remotely flown. Okay, whereas it completely functions as good as your aeroplane, or the people who flies aero modeling aeroplanes also. It is almost similar to that. The flying is almost similar to that. But since this is beyond visual line of sight, it requires ground control stations. Lot of monitoring, lot of signals, lot of tracking, telemetry is required for this flying of this kind of fixed wing UAVs. Okay. So basically, normally when this kind of aeroplane is flown, there are two people. One person who is actually flying or monitoring the flying activities, and the other person is monitoring the other activities, like whether they wanted to shoot a particular area or whatever activities they need to perform, or whether they want to trigger the missile attack or whatever, that is being done by another person. So there are two people who are working, but these two people are only pilot in command. That means they are command, but there are at least 10 people in backend sitting and monitoring and observing all these operations. There is a knock where they monitor entire operation carried out by these drones. Okay, so that is how it is. So they normally sit in a container kind of, or a base where they are operating and connecting to this aircraft. So your aeroplane, fixed wing aeroplane, is in Afghanistan. There are some people who are actually bringing it on the runway. They are making sure that that aeroplane is equipped with whatever required payloads and all the things, and they will put it on runway. And then person sitting in US is actually triggering and starting to make it take off, and then flying over the period of whatever it is, maybe 2 hours, 4 hours, 10 hours. Sometimes they fly for 24 hours continuously. There will be people changing in the shifts. Like two people will come and follow and fly that aeroplane for continuous 8 hours. It will keep on flying. Next shift will come and take over. Or not necessarily the people who are sitting in that container. There might be some other container who is somewhere other two pilots are sitting. They will take the control of that aircraft. Okay, that's how these missions have been carried out. So continuous missions are carried out on such kind of fixed wing UAVs. Okay, so let's see what are the parts. Propulsion systems, fuel system, control system, avionics, takeoff and landing, and payload system. So these are all 6 important components of fixed wing RPA. Okay, so let's see each one by one. The propulsion system can be 2 types. One is brushless direct current motor, that is a small BLDC motor, what we normally call, or it can be an IC engines. So basically, brushless direct current motor or BLDC is high power to weight ratio, available in wide range of starting from 5 grams. Okay, 5 grams, 20 grams, even 50 grams, 100 grams also motors are available. Best suited for nano micro categories. Okay, these are for small fixed wing. These kind of are very small. Basically, these are used for any kind of a stealth operation or a limited area of operations you want to do. These are low noise helping keeping, because you will not hear the noise or they will not make noise of the motors. Okay, but these are very limited, because now again these BLDC motors means this will be powered by batteries. So battery will have definitely less endurance. Compared to that, if you see IC engines, they are conventionally used systems, provide higher endurance than BLDC, best suited for medium and large category. IC engines are noisier than the BLDC motor. So that's why they are always flown at a very height, 2000 feet, 4000 feet, 10,000 feet kind of thing. And either these motors or these IC engines, they are connected with propellers. So they require propeller which generates the thrust or provide the thrust rotating in size in a particular directions. Okay, these propellers are made of wood or industrial or small grade plastic or even carbon fiber. Okay, so earlier days you will see some vintage, like Soham is there at the resort. You might see in a pantry there are some vintage propellers, big air propellers of World War II aircrafts have been kept. We have kept there. So we are actually trying to build lot of such kind of things which is there with us at Bombay site. Okay, so lot of things are there which is not used, but as a souvenir we can keep it. So we brought all the propellers, this kind of propellers over there so that people can see it. So we will be bringing lot of things, like we have one helicopter also, plus some parts are there. So we'll try to bring one by one, because these also need transportation only. So whatever is possible, whenever we are traveling from Bombay to Igatpuri, we are carrying some other equipments over there and keeping it for display and all the things. So so propellers, either they are made of wood or industrial or a small grade plastic or even carbon fiber. So carbon fiber propellers are very expensive, but they are very lightweight. Like if you see in jet engines, those wings, what they are made, the blades, they are made of titanium. That's why they are very very expensive, because they are moving at a very very high speed. They need to, that tensile stress has to be, they should able to handle that kind of pressure on it, or it will in flight अगर आपका समझो propeller break हो गया या आपका blade break हो गया, it will be a disaster, right? It will be very very disaster. आपका engine पूरा blow out हो सकता है at point of time. So that's why they have to be made of very high grade materials. Okay. So that is propulsion system. Fuel system. Now fuel system, there is a lithium based batteries. LiPo or lithium ion are mostly widely used batteries. LiPo batteries can be custom built for different shapes and size. Lithium ion batteries are capable of higher endurance flights compared to lithium polymer. Energy density is far less than IC engines still, okay, because the liquid fuel what we use in a normal IC engines, which can power drones for almost like 2 hours, 4 hours, 8 hours, 12 hours, 24 hours maximum. I have seen the IC engines flying mostly up to 48 hours also. Okay, so depending upon that, and you can keep on fueling it also, like your B2 bomber you have seen, right? It can keep on flying in air by as far as the fuel is been refueled on in air itself also. So same thing goes for these also. If you are able to fuel these kind of drones, it can keep on operational also for almost like 24 hours to 48 hours. It is stored in a tank mounted on the fuselage. It could be glow, nitro fuel, gasoline or diesel in weight. Better thrust to weight ratio than lithium based battery. So if you see the fuel, whatever I am putting, the weight amount of fuel what it is, it gives me a very longer endurance compared to the battery system here. There are some alternative options are being also planned, where they are being currently in prototype and testing, like hydrogen powered fixed wing as well as solar powered fixed wing. But these are still in development or prototype. Like there are some testings has happened which have been successful and they're flying, but they're still not been made at a mass level, or they are not still in that level where they can mass produced and used extensively. Still they are in a prototype systems. Okay, so mostly widely used is lithium based for smaller flights and all the things, whereas for a longer endurance you use liquid fuels. Okay, so when you are flying the drones, you need to understand the basic controls. I think those people who have flown the drones, they might be aware, but those people who are not flown, so you have two joysticks on your drones. Okay, one is on your right side and one is on your left side. So you always control by your thumb. Okay, thumb and the first finger. So that is called pinch. Okay, pinch. You have to use a pinch. So on the right side, whatever you have, that is called as R. R for roll motion. R P. So you have to say R P T Y. Okay, so right side is R P T Y. So right side is roll. Okay, so you can roll, lateral motion. When you are moving your stick on laterally position, left and right, you are doing roll. Okay, so roll right or roll left. When you up and down you are actually pitching. Okay, so pitch forward, pitch back. And on your left side, you have again lateral motions. So when you say your right or your left, and up and down is throttle up, throttle down. So you see here, when you are changing your controls, from fixed wing. In a fixed wing, you have a level flight. You say pitch up and pitch down, your right, your left, roll right, roll left. So only 3 are there. But in a drone, what happens? You get 4 motions. What 4 motions? Pitch forward, pitch back, roll right, roll left, your right, your left, and the fourth one is throttle up, throttle down. So you have a 4 controls. Okay, so your roll, pitch, throttle, and yaw. So R P T Y. Okay, remember these words. Okay, do you know what configuration we use when we are using a controller? What normally the configuration we use?
Mode 2.
mode 2. Okay, so there are different modes. So predominantly we maximum people use mode 2 configuration. What is with my mode 2? Means on your right side you have roll and pitch. On your left side you have throttle and yaw. If you reverse this configuration, it is mode 1. Okay, so normally our configuration is called mode 2. Okay, so you can see here, this is a picture of the transmitter over here. You can see on your right side, the up and down is pitch, left and right is roll. And on the left side, you can see up and down is throttle and left right is yaw motion. So you see channel 1 is your roll, channel 2 is pitch, channel 3 is throttle, channel 4 is yaw. So this configuration is called mode 2. If in case you reverse this from this side to this side and this side to this side, it will become mode 1. Okay, any questions over here? So mode 1 is not so much used. Okay, it is been used earlier, some people uses, but maximum mode 2 configuration is being used. Okay, so when you are flying, okay, so normally our flying is RPAS flying. When we are flying a drone for some kind of a mission, okay, so we need to have a ground control station. For example, you are flying agriculture drone, for example. In that scenario also, it is not advisable to fly a agriculture drone in a manual way, because you will not use the efficient way of drone endurance capacity. Okay, जो आपको like 8 minutes में आपको 1 एकड़ करना होता है ना, in that 8 minutes you will hardly finish I would say 10% of your power, 10% of your drone endurance capacity. Okay, मतलब आप 1 एकड़ complete ही नहीं कर पाओगे. Okay, only 10%, 20% max complete करो. So that is not efficiently flying, because you cannot control drone manually. You are not so efficient, no perfect flying the drone. How better you good flying you might be. Okay, still you cannot do it what autonomous flying can do. So normally when you are doing such kind of mission, you have to have a ground control station. You can use mission planner software, which is available for Windows platform. Okay, so mission planner can be used for a configuration utility or as a dynamic control supplement for your autonomous vehicle. That means you can define how the drone has to be flown here. So you can start from here, you can take off, it will go, it will have a uniform pattern of flying. So when you see, I will share you some or I will show you when we are at Igatpuri, some pictures, some videos about the farmer who uses drone for spraying activity. So the drone will go fly straight in paths, it will move, and so in within that 8 minutes flight time or 10 minutes flight time, it will completely complete 1 acre of land spraying. Okay, so you can control everything, right from amount of the spray has to be done, how much water has to flow, I mean the pesticide has to flow, all that thing can be defined. So that is what is your mission planning. So that is basically once you become a pilot, you maybe you join some organization as a pilot, or you may start your own business of agriculture or drone services or something like that. So the OEM will basically train, or you can get a separate training also for flying the agriculture drone, like how the agriculture drone needs to be configured, because the software what they use for this, that's a GCS software. Okay, that's the license software. Every company who gives you a drone, they will give you a GCS software. It's a license subscription based software. So if you are flying a drone for that activity, they will activate your license for that purpose. There is a separate charge. It's a subscription based charge. Okay, so they will give you, and they will show you first, they will give you a demo how to do and use it and show you and all things. Then you can start using it on a regular basis for yourself. So basically they will teach you how to set the mission planning, how to set all the things. So there is a separate course for agricultural drone flying. Okay, there could be a separate course for surveillance drone flying. There could be a separate course for cinematographers also. So there are like this. So we are actually now going to start on the agriculture drone pilot course as well as a cinematographer course also. Okay, maybe in August probably we'll be planning to start it off. Okay, so we are actually talking with couple of organizations and the people who are veteran in so this kind of trainings. They will be actually coming and training our students who enroll for those kind of advanced courses. Okay, because we are getting a lot of inquiries on that perspective also, like after becoming a pilot you need to learn all other additional skills also. Okay, it's not about just like learning the basic things. Now here you will learn about flying the drone, how to fly the drone, how to do regulations, how to understand the regulation, how to follow safety, security procedures, all the things, how to take the approach, all those things you will be learning, the basic thing about flying the drones, and you become a pilot now. But then you have to apply that knowledge, apply for further, I mean, depending upon your interest. Somebody might be interested only doing aerial photography or videography kind of. Somebody might be interested in doing surveillance activity. Somebody wanted, like there was one student who wanted to know how to fly a drone near the what is that, the high rise buildings, because he want to fly the drones for those high spray jets are been cleaning the glass panes of the buildings. So he was into that, into security agency kind of thing. So he wanted to learn that. So in India, nobody is giving that kind of training as of now, because nobody has that kind of drones for training purposes. So I suggested him some outside, which is outside available. Either he can contact with them, or he can develop some kind of work along with them. Okay, that is what I told. So that's why you should. So drones now has many functions ranging from monitoring climate change to carrying out search operation after natural disaster, photography, filming, delivering goods. Like when you are delivering from one location to the, you have to define. Like in Bangalore now they are testing delivery drones. Okay, so delivery drones में क्या किया उन्होंने, एक particular warehouse है. From that one particular warehouse, the drone will fly, and they have selected one or two societies, big societies, where they have made that the drone will fly from the warehouse and it will go to that particular society only. So that's how the delivery is happening between warehouse and that particular society. This is just for a trial basis, because in future it will not be a particular society, right? It can be gone for any other society. But here they are just trying and testing, okay, how to plan the mission, how to plan the flight plan, what are the challenges they will encounter when the drone is flying from warehouse to that particular society and back from society to warehouse, how the things are happening. That's why they need to do some trials, right? Similarly, in Mumbai also there are people who are testing from Vasai to Bhivandi. Okay, there is a delivery drone which is flying from Vasai to Bhivandi area. Okay, for delivery options. So that is also testing is happening. Even in Gurgaon also there are couple of organizations like Delivery. I have heard, even I think Blinkfit, they are also trying to test this kind of operations. But when we are doing this kind of operation, you need to feed the path. You need to plan. You cannot fly on your own the drone. That has to be autonomous. Similarly, even the air taxis which are planned, like in Bangalore there was a testing happened, and there is a service which was started. So those also air taxis will be also autonomously fly. There won't be a pilot inside the taxi, the air taxi. Okay, it will be auto. You have to just go, take your seat and sit. It could be 2-seater or a 4-seater. You just go and sit inside that aircraft. After everything is there, it will lock the doors and automatically it will take off. It will go to destination, it will land, and it will open the door. So everything will be autonomous. But then people need to have that confidence. People need to have that kind of testing. People needs to have that kind of prototype testing has to be done on that particular. I mean, the autonomous flight testing also has to be done. And people should have confidence on the system, because जब aeroplane fly होता है तो normally pilot होता है. So you always have a trust that okay, there is somebody who is there, trained, managed, can manage the emergency situation. But ऐसे scenario में जो pilot ही नहीं है, तो that what normal person will able to do. Okay, so it will be like little bit challenging in that respect. So you have to make sure that whatever testing you are doing it, you are thoroughly doing the testing on the missions. Okay, so takeoff and landing and recovery of this kind of fixed wings, right? As I said, takeoff is either hand launch, or it can be catapult, or it can be a runway takeoff and land. Okay, like Predator drones. There are some drones which are being, I mean, the fixed wings are being recovered using the parachutes. Okay, or some are net or zip line also. Okay, so zip line which actually captures the drone and it brings to stable point. Okay, so that is how normally the takeoff and landing or the recovery system of these fixed wings are there. Okay, now what are the applications? Basically fixed wings are used in surveillance, agriculture, mapping, wildlife protections, constructions, mining. So basically where you have to cover a bigger land area. Okay, big scale, like last year Gujarat government has flown fixed wing over their entire district, and they have captured the entire geometrics data, okay, of their vegetations, land, water bodies, all whatever they have, they wanted to capture and bring a one particular map, and they want to set up a complete body which will keep on monitoring and doing these kind of activities. So they have set up that kind of team over there, which actually regularly flies this kind of fixed wing. They are actually flying a Teleron drone kind of thing. It's a fixed wing drone, and they capture all that data and then they process that data for day-to-day usage for people to use it. It could be various departments, various organizations, even farmers and all those people can use that kind of data. That is why they are doing that project. Okay. Similarly, it can be used for surveillance, mapping, agriculture, construction, mining. Where the area is quite big, there you cannot fly small drones and all things because you are limited with the endurance capacity. So when you have to cover a larger area and more precise data you need, you will be flying the fixed wing. Okay, so this is last slide about the fixed wing, comparison of the fixed wing with respect to multi-rotor. So fixed wing is unable to maintain the fixed position, so it is not able to hover at one particular location. Can only fly in horizontal forward direction, so it can always fly in a horizontal direction. Required hand or mechanical launch, catapult, or even maybe a runway for such kind of fixed wing aircraft. But it has longer average flight times. Okay, compared to multi-rotor, it has a longer average flight times. Can carry heavier payloads. Okay, greater stability in wind, generally higher flight speeds. Okay, again it covers a large area. That's what we're talking about, a higher flight speed. Greater stability in the wind because they are aerodynamically designed. Okay, that's why they are more stable. Okay, and it can carry heavier payloads. Okay, because the type of design of the fixed wing are always bigger. So you will always see medium class, large class. Okay, there's kind of drones or fixed wing UAVs you will see. Compared to that, multi-rotor is easy to control and maneuver. Say fixed wing flying is a different compared to what you are flying in a multi-rotor. Okay, multi-rotor is very stable, very easy to fly compared to fixed wing, because fixed wing you have to continuously monitor because it's always continuously like in multi-rotor. If you find that you are finding difficulty, you can hold it, right? So it will hover at particular location. But in a fixed wing, it cannot, right? It will be continuously in a forward motion. So it's very difficult. So you have to continuously see how it is flying and you have to monitor it continuously. You cannot leave it on its own until unless it is flying autonomously. Okay, have ability to hover. The multi-rotor has ability to hover, as I said, vertically take off and land. So these are the two important benefits of the multi-rotor. Okay, ability to hover and vertically take off and land. That is the advantage of the multi-rotor UAV. Why drone has become popular was only because of this. Okay, the hovering capability and vertical takeoff and landing. Okay, but it has limitations, limited flying time, small payload capacity. Okay, less stable in wind. So there is no aerodynamics in the drone. It's just a frame. Okay, and the four motors, four propellers are rotating and pushing the air down, and it is flying in the air. So small payload capacity, less stability in the wind, lower flight speed. Lower flight speed means compared to fixed wing, the multi-rotor will be moving in the air very slow compared to whatever the fixed wing can move. Okay, that's why it's saying lower flight speed. Okay, so any questions you have on the fixed wing? No? Okay, let's go to the next topic. Next topic is rotorcraft, which is a very